In case of two-dimensional parity check, so what we'll do is every row, one additional bit, we are going to use redundant bit. So if this is the row of information I want to send, this is the parity bit, redundant bit. For this row, this is the redundant bit. For this row, this is the redundant. For this row, this is the redundant. Okay, row wise one and column wise. For this column, this is the redundant. For this column, this is the redundant. For this column, this is the redundant, like this. Okay. So if you observe this, in the first row, how many ones are there? 1, 2, 3, 4, 5. 5 ones are there in the message. But we want even number of ones. But we had odd number of ones. So the redundant bit is 1. So that including redundant bit, number of ones in the first row are even. Similarly, second row, including redundant bit, number of ones are even. Third row, 1, 2, 3, 4, already even number of ones are there. So redundant bit becomes 0 to make even number of ones in the row. Similarly, fourth row, 1, 2, 3. So redundant bit will be 1, so to make even. Okay, that is how these row-wise redundant bits we have derived. Next, column-wise. So first column, 2 ones are there, even number of ones, so redundant bit is 0. The second column, 3 ones are there, odd, so redundant bit is 1. So that altogether is even. Third column, 2 ones are there already, even, so redundant bit is 0. Fourth column, 3 ones are there, odd, so redundant bit is 1. Likewise, it is being derived column-wise. Then finally, for this column, this is C. Last column, see, odd number of ones are there, so redundant bit is 1. And for the row, last row, so odd number of ones are there, so redundant bit is 1. Now this is what is being sent to the receiver. Sender will transmit this information. Sender will transmit this information as a block. Rows and columns together as a block will be transmitted to the receiver. The moment receiver receives this, then if same thing is received as it is, okay, the same thing is received as it is, if we assume that same thing is received as it is, then so first row including this even number of ones, no error. The second row, even number of ones, no error. Third row, even number of ones, no error. Fourth row, even number of ones, no error. Last row, even number of ones, no error. Column wise, first column, even number of ones, no error. Even number, no error. Even, no error. Even, no error. Even, no error, likewise. So that means we are assuming that this is received as it is. Okay. Initially, we are assuming that everything is received as it is. No errors. Now, let us see if there is one error. If there is one error, okay, if this case, suppose now instead of this 1, we have received a 0. Okay, instead of this 1, we have received a 0. Now let us see whether we are able to detect this or not. Okay, so if you see the first row, even number of ones, so first row is having no errors. The second row, 1, 2, 3, 4, 5 ones are there odd, so there is error in the second row. Second row is not received correctly. There is something wrong in the second row. Third row, 1, 2, 3, 4, even number of ones, so third row is correct. Fourth row also even number of ones, correct. Fifth row, 1, 2, 3, 4, even, correct. Okay, except the second row, all are correct. Now column wise, so first column even, correct. The second column even, correct. Third column, only 1 is there, so odd, so third column is wrong. Fourth column, even number of ones are there, correct. Fifth column, even correct. Sixth column, even correct. Seventh column, even correct. Eighth column, even correct. Now, if we talk about, so the third column and second row are having errors. That means the intersection of second row and third column is representing this particular bit, which we have not received correctly. So probably instead of 0, we should have received 1. That is the correct value. So in a block parity, this one error is there detected and can be corrected. Now, suppose there are 2 errors. This one is received as 0 and this one is also received as 0. Okay. So originally they are 1 only. 1. This is also 1. So let us assume that they have not received correctly. This one is received as 0 and this one is received as 0. Now let us see whether what is happening in the first row. So even number of ones are there. So first row is correct, no errors. The second row 1, 2, 3, 4, even number of ones are there, correct. Third row 1, 2, 3, 4, even number of ones, correct. Fourth row 1, 2, 3, 4, even, correct. Fifth 1, 2, 3, 4, even, correct. So all rows are okay. No errors in any of the rows. Of course. So there are 2 errors in the second row. But what we are given number of errors not detectable. Okay. So that is what is being observed at this point. Now let us see column wise. In the first column even, it is correct. The second column even, correct. Third column odd, so wrong. Fourth column even, correct. Fifth column odd, wrong. So sixth column even, correct. Seventh column even, correct. Eighth column even, correct. So row wise every row is correct, but third and fifth columns are wrong. Third and fifth columns are not received correctly. There are something wrong. In the third column there is a error, and in the fifth column also there is an error. So in this particular column and in this particular column errors are there. That means maybe this 0 we have received wrongly. Instead of 1 we might have received 0. And in the first row maybe this element is wrong. Instead of 0 we have received 1. So maybe that is wrong. Okay, possibility is at this point. Or instead of 0, suppose this should be 1, but we have received 0. Maybe this should be 1, but we have received 0. That is what the wrong may be at this point. Then third row, this might be 0, but we have received 1. This might be 1, but we have received 0. Or in the fourth row, maybe this 1, but we have received 0. Maybe this is 1, we have received 0. Or maybe in the redundant row, instead of 1, we have received 0. Instead of 1, we have received 0. So possibility may be any of these elements in this column, any of these elements in this column. But every row is saying that every row is correct. Means these 2 columns belongs to a particular row is having problem. Maybe the first row, these 2 elements, or second row, these 2 elements, or third row, these 2, or fourth row, these 2, or fifth row, these 2 are having errors. So we cannot able to identify, but we can able to identify that there are errors. Okay, so this is how we can able to identify multiple errors. Okay, but cannot be able to identify the location of the errors. That is one. Then we'll see another example in the next screen, suppose now there are 3 errors. If you see this, so this is instead of 1, a 0 is received. Instead of 1, a 0. Instead of 1, a 0. Now let us see. In the first row, 1, 2, 3, 4, 5, odd. So error. The second row, 1, 2, 3, 4, 5, odd, error. And third row, 1, 2, 3, odd, so error. Fourth row, even, no error. Last row, even, no error. Column wise, first column, okay. The second column, odd, there is something wrong. Third column, even, no error. Fourth column, even, no error. Fifth column, even, no error. Sixth column, even, no error. Seventh column, even, no error. Eighth column, even, no error. So what it is indicating is 3 rows are having errors and one column is having error. So of course, errors are there in this, even number of errors are there in the column, but unable to detect. Okay, only odd number of errors in this column detectable. So odd number of errors in this row detectable. Odd number of errors in this row detected. Odd number of errors in this row detected. But exact position is not. Only thing is the extension of this row and this column will identify this particular bit. But what about these two? Even number of errors in the same column undetectable. That's what we have seen. Okay. So this is how errors can be detected but cannot be corrected even by using block parity, because only this can be detected and corrected. But these undetected. Row wise they are being detected. There is something wrong in this row. But anywhere the problem is. Okay. The same thing is even number of errors in a row, even number of errors in a column, undetectable. Okay. Even number of errors in a row, even number of errors in a column are undetectable. If this is 1 and this is 0, and this is 0 and this is 1. You see 1, 2, 3, 4, 5, 6, no errors. This, even no errors. This 1, 2, 3, 4, no errors. 1, 2, 3, 4, no errors. 1, 2, 3, 4, no error. All rows are okay. But in 2 rows, 2 errors are there, but undetectable. In this column, even no error. In this column, even no error. In this column, even no error. In this column, 1, 2, 3, 4, even no error. In this column, 1, this is 1. 1 and 1. 2 error. 2 ones are there, even no error. Even no error. Even no error. Even no error. So what we got? No rows are having error. No columns are having any error. But actually speaking, in this row, 2 errors are there. In this row, 2 errors are there. In this column, 2 errors are there. In this column, 2 errors are there. So even numbers per row undetectable. Even numbers error per column undetectable. So this is the problem. Even in the block parity or two-dimensional parity mechanism. So that is why even this is not being preferred in communications. Okay, that is why even this is not being used.